Welcome to our talk about writing better code in Dylan. It's not the first time that the two of us, Hannes Mehnert, next to me, Andreas Bruck, my name, talk about Dylan. We did so before, but the last time we didn't really get into looking into the details of the programming language and all the features that make writing in Dylan better than writing other programming languages. And so this time around we want to go into detail there and explain what it's about and what makes it useful. So there are certain requirements one as a programmer has towards the programming language. It's a lot of them, some have to do with the language, some with the support around the language. A programming language should be powerful and expressive, so you don't have to write everything like 5 or 10 times. You want it to be universal. You want to be able to solve any problem in your programming language of choice. You want it to be easy to learn. It's no good if you have to spend years and years until you understand how to write good programs in a programming language. You want your code to be fast. You want your code to be easy to read. You want to have an open source implementation. You want to have tools available, libraries, etc., etc. So if you look at existing programming languages, they fulfill some of the requirements here, some of the requirements there. C, for instance, is really, really widespread, and it's pretty easy to find a library doing things in C. It's universal. People write all sorts of code in C. Performance is very good. Programs written in C are usually very fast. It's unfortunately not very powerful. There are certain expressive features just lacking in C, like the closures or real object system. You can do things to work around that, but it really doesn't cut the cheese. Of course, the support for tools in C is very good. Another language that comes to mind is Perl. Perl is pretty much universal. Well, not exactly everything is written in Perl. For instance, the Perl interpreter itself is written in C and not in Perl. So that's already a sign that it's not a universal language. It has certain niche markets. It's certainly powerful. It's very easy to write complex stuff in Perl. Well, it gets a little tricky if programs grow bigger, because at some point you start not to understand your language, your program anymore. It lacks certain abstractions, but on the other hand, you have lots and lots of libraries available. You go to CPAN, you find what you need, and you glue 2 or 3 pieces together. That's where Perl excels. Performance is good as long as you're manipulating strings. For everything else, it becomes slower. It's not easy to read. So the average Perl code looks like somebody has fallen on the keyboard. There's an open source implementation, yes. If Emacs counts as an IDE, there's an IDE. But you see, there are certain niches fulfilled by different languages. And our language of choice is Dylan. And we think it excels in a lot of the points named here. So it's not easy for a language to get to the point where you really say it's useful for everything. You have lots and lots of hype languages, like Ruby, for instance, is the latest hype, which does have some pretty nice features, but unfortunately, again, performance isn't so good. We do Dylan for quite a while now, and we have a track record of being successful with the programming language in contests. The ICFP programming contest is something we compete in every year, and it looks like odd years are lucky years for us, because we made it quite a number of times. And the programming contest, the ICFP programming contest, is very interesting because it is a real-world test for a programming language. The challenges in that contest are usually not, they don't have a proper solution. So it's not like your standard university test where you can get 10 out of 10 marks for solving the problem correctly, but the problem is so hard that there's no single correct answer, and you have the programs compete against each other. You have a limited time to solve the problem, so the expressiveness of your programming language is important. If you have to write everything 10 times over and over again, you just won't be able to finish your program in time. So in, this year, for instance, there were 168 teams. About 30 of them wrote in C, and of the 30 programs written in C, I think only 1 or 2 managed to even make it to the final round. So the other 29 crashed or produced no output or problems like that. They just didn't manage to finish the specification in time, let alone optimize it to compete.
There were also about 10 implementations in Perl this year, and all of them failed also. They thought quite hard about, on the mailing list, about how to exploit the others' code and send lots of messages, because Perl is good at string manipulation, and other languages like Python or Ruby aren't that good at string manipulation, and you had only limited time for each turn this year. So you had to answer in 5 seconds, and the Perl guys thought how to disqualify other teams.
Yeah, we didn't care about performance at all in that contest, actually. It just was fast enough to begin with. And yeah, that's one of the misconceptions many people have, that there's something like so-called scripting languages, which are high-level languages when looking at the language features, but who are notoriously slow to execute. So people think, yeah, scripting languages, high-level features must be an interpreter. Interpreters are slow. On the other hand, you have languages that are compiled, and those don't have that high-level features, so you have to work harder, but you have to work harder to get high-performance programs. And that's simply not true. It's possible to get best of both worlds, to get the features and the performance. And we've shown that. Yeah, the history of Dylan is interesting. It started out as a dialect of Lisp. Now, Lisp has been around, well, basically since the beginning of the computer era. And also the lambda calculus, which is the theoretical background behind Lisp, has been there for quite a while. Dylan is notorious for being the Lisp dialect which doesn't have the braces. It has a regular algo-like syntax. So all the people who don't like Lisp because of the syntax, try out Dylan. It might be the language for you. It started as a development at Apple Cambridge Laboratories for the Apple Newton. It wasn't used for the Newton actually because 1 megabyte of runtime code size was deemed excessive at that time. Still, Apple continued development of Dylan for their host platforms, for the desktop computer platforms. And together with them, both the Carnegie Mellon University and a company called Harlequin worked on the Dylan standard too. Yeah, Apple, most people probably know OpenMCL these days, Macintosh Common Lisp. The same folks who worked on Macintosh Common Lisp also worked on Dylan for Apple. Then one of the 2 or 3 open source Lisp compilers available is CMU Common Lisp, or these days SBCL, which is the same source code. And these folks developed at Carnegie Mellon University for the Dylan project. Actually, the project leader was Scott Fahlman, who's known for inventing the smiley. So he's been around for quite a long time. And, Harlequin is a very little known company, but they used to be, they're bankrupt these days, but they used to be the main manufacturer of LispWorks, a commercial Lisp compiler. So basically you had all those people with a Lisp background, and what they tried was basically doing the next generation Lisp. They had that Common Lisp standard in the 80s, which was basically we tried to standardize what's there. If you ever looked at Common Lisp, it's a very, very powerful language. It's probably the most powerful computing programming language on that planet. But it's very, very hard to learn. It's got in the standard 700 or so function calls, and it's got an ugly syntax. It pretends to be an easy syntax with all the braces, but if you look at reader macros and stuff like that, and it's ugly and hard to understand for a beginner. So they try to come up with a clean design. They overdid it a little bit. There are some corner issues which they shouldn't have removed from the language, but did remove anyways. I'll maybe come to that later. But mostly what they came up with was something very nice, a cleaned up version of Lisp with a nicer, more regular syntax, easier to learn and optimized for being high performance compiled. So these are basically the language features you find in the language. It's object-oriented. Everything you touch in the language is an instance of a class. This is also the case for all the so-called primitive types known from other languages. So in Java, for instance, you have that integer fundamental type with a small I, and then you have the big I integer, which wraps an integer into a class. You have to encapsulate and decapsulate all of the time. And if you ask them why they did that, they say, oh, there are performance reasons. In fact, you can show that you don't have to do that you can put everything into a class structure. So that's also a difference to Common Lisp. In Common Lisp, not everything is an object. There's the Common Lisp object system clause, but it's basically attached at the side of the Lisp standard, and you have fundamental Lisp types which are not instances of classes. So until you don't have that anymore. There's multiple inheritance. And again, Java is a language which dropped multiple inheritance. And if you write Java, you'll miss it. It's really so useful to just have some kind of functionality you mix into your class by inheriting from just another class. And for encapsulating behavior of classes in different abstract superclasses. And when you look at multiple inheritance in C++, it comes with a number of problems, because if you inherit the same class over multiple paths, you might end up having the same data slot twice in your class or not, depending on whether you do virtual inheritance or non-virtual inheritance, and the mind starts to boggle. And what's done in Dylan is so-called superclass linearization. It's also a trick borrowed from Common Lisp and the Clos Common Lisp object system. Basically what you do is take all the superclasses and sort them into a list, into a linear list. And if you inherit from some class twice, the second inheritance path is removed. And that removes a lot of the hassle you have with multiple inheritance in other languages. It also removes lots of the performance problems multiple inheritance has. Multiple dispatch is a very peculiar thing. Most people who write object-oriented programs somehow think that object-oriented means we have classes, and classes consist of data and functions. And you call a function on a class, or you send a message to a class. That's what you know from C++ or from Java or from Smalltalk. But in practice, you don't have to. You can separate the functions and the data, and in Dylan actually classes encapsulate just data, and behavior and polymorphism of functions is encapsulated in so-called generic functions. It's pretty easy to explain what it's about. If you have A plus B, then plus is a function of A and B, and it's not natural to attach it to either A or to B. It's just a function plus. As in a regular language, you have verbs and nouns in a human language, and so you have in Dylan objects and functions. And multiple dispatch just means that for every possible permutation of arguments to a function, another method is selected. We will have an example later if that's confusing, but that's something to keep in mind. Multiple dispatch is a superset of the so-called receiver model of Smalltalk or C++, and it's more powerful, and in some instances it makes writing code much easier. Functions in Dylan are first class. That means you can put a function into a variable, you can pass a function around, and